The amount of plastic has increased at an alarming rate since the invention of the material, causing environmental problems at a global scale. Nowhere in this issue more visible than in the Philippines, whose population of 117 million people across 7,641 islands produces over 1/3 of all oceanic plastic waste in the world, according to our World in data. In 2021, the World Bank conducted a study on plastic circularity in the Philippines and found out that there is a recycling capacity gap of 85%, that only 28% of total plastic waste was recycled in 2019. Well, this was my photo taken during one of the coastal cleaning along the Manila Bay. And so now we are in the plastic generation. My discussion of plastic generation would follow this linear flow of extraction, production, consumption, and disposal. Plastic is light yet stable, corrosion-resistant, and have excellent insulating properties. A product of fossil fuel, produced as packaging material, but dangerously, when disposed, has a lifespan of more than our lifetime. The 20th century saw a revolution in plastic production where the first fully synthetic plastic appeared in 1907. Deeply infiltrated in all aspects of our daily lives from infancy to adult life, with more plastic generated during the pandemic due to the increased healthcare waste from the use of face masks and other personal protective equipment, as well as single-use plastics from food deliveries and online shopping. Now, however, they also are part of the major infrastructure enabling transportation, manufacturing, and communication. Sad to say, plastics are the largest, most harmful, and more persistent fraction of marine litter, accounting for at least 85% of total marine waste. The packaging is a major reason for 36% plastic production. 46% of plastic waste is being landfilled, 22% becomes litter, 17% incinerated, and 15% collected for recycling, with less than 9% actually recycled. Plastics disposed, broken down into microplastics, are now everywhere in our natural environment. They are becoming part of the Earth's fossil record and a marker of the Anthropocene, our current geological era. They have even given their name to a new marine microbial habitat called plastisphere. Plastics are health risks. They are present in our food chain, ended up in our waterways, contaminating our drinking water and the fish we eat. The burning of plastics releases toxic gases like dioxin, furans, mercury, polychlorinated biphenyls into the atmosphere, and poses threats to animals, vegetation, and human health. And it brings domino effect, plastic and climate change. So how are they related? Plastic pollution can alter habitats and natural processes, reducing ecosystems' ability to adapt to climate change, directly affecting people's livelihood, food production capabilities, and social well-being. So what about the intersectionality of plastic and climate change? Climate change is a slow onset change. It's a natural phenomenon. Historically, climate is naturally changing but in slow occurrences. Fast forward, everybody has been talking about climate change, its implication to environmental security and human health and safety. But not everybody understands that commodification of plastic is a game changer in climate change. Well, just to give you a short background on the intersectionality of climate change and plastics, if you will recall in history, during the Industrial Revolution, fossil fuel was used as sources of energy to run industries, transportation, electricity, and manufacturing, followed later on by economic development in Europe. Through time, these economic activities emitted carbon dioxide from industries and manufacturing sectors, methane, nitrous oxide, among others, increasing the greenhouse gases in the lower atmosphere. The continuous emission from these anthropogenic activities or human activities, like the commodification of plastics, changed the landscape of gases in the atmosphere. So let me show you the gas composition in the lower atmosphere. So just a glimpse of the gas landscape in the troposphere. So the atmosphere is just made up of several layers. The lowest layer, the troposphere. And the composition of gases in the troposphere is composed of nitrogen, 78%, oxygen, 20%, and small traces of greenhouse gases like carbon dioxide, argon, helium, methane, and ozone. So just small traces of these greenhouse gases. As more greenhouse gases are emitted from industries, manufacturing companies, vehicle emissions, deforestation, landfill, more greenhouse gases are emitted. Thus, more heat is absorbed and blocks the solar energy from escaping back to space. Now, let me further show you these two pictures. So we have here in picture A, so you have the Earth's surface, and then the blue color is the troposphere, the atmosphere, which is mostly composed of nitrogen, oxygen, and small gases, small traces of greenhouse gases. And on top, so you have greenhouse gases, carbon dioxide, methane, and then nitrous oxide. So we receive solar radiation, but then re-radiated back to space. So there is less re-emitted heat as needed on the surface of the Earth. However, due to the increasing human activities, there is the increasing emission of carbon dioxide, methane, nitrous oxide, and other greenhouse gases. Now, the tendency of these greenhouse gases is to occupy more space in the atmosphere. And so, in illustration B, so again, there is solar radiation coming from the sun, but due to the presence of these greenhouse gases coming from the human activities on the surface of the Earth, now there is less heat escapes into space simply because these greenhouse gases absorb heat and blocks solar energy from escaping back to space. And so less heat escapes into space that increases global temperature. And this increasing global temperature affect water cycle, rainfall, wind pattern, and snow. So this led to the changing weather patterns in terms of intensity, frequency of climate-related hazards. So weather patterns means climate in science. So you have learned that when we talk of weather patterns, we're talking of climate. All right. Now, let's take a look at the residence time of these greenhouse gases in the troposphere. When you emit ozone and ozone-forming chemicals like nitrous oxides, they are relatively short-lived in the troposphere. For methane, mostly coming from decaying materials from the landfill, it's short-lived for 25 years, but more potent than carbon dioxide. It means that it absorbs more heat compared to carbon dioxide. In the case of carbon dioxide, once added to the troposphere, it hangs around for a long time, between 300 to 1,000 years. So even if we will not dispose plastic at present, we will not burn plastic at present, plastic is still there. Plastics emit carbon and a substantial contributor to global greenhouse gas emissions. In 2019, plastics generated 1.8 billion tons of greenhouse gas emissions, 3.4% of global emissions, with 90% of these emissions coming from their production and conversion from fossil fuels. By 2060, emissions from the plastics life cycle are set to more than double, reaching 4.3 billion tons of greenhouse gas emissions. Furthermore, airborne microplastics have been found in remote regions, including the Arctic, where they may contribute to accelerated warming through absorbing light and decreasing the surface albedo of snow. Now, if we continue business as usual, then life would be more unbearable to the vulnerable sectors. Increasing global temperature affects rainfall and wind patterns, and that gradually change weather patterns or climate change. Climate change is an abstract concept, and what we experience related to climate change are more frequent and violent hazardous events. When not properly addressed, results to disasters and vulnerabilities. Let's take a look at this photo. So, total disaster events by type, 1980 to 1991, 1999 versus 2000 to 2019. So, in 1980 to 1999, well, you have flooding and storms, more occurrent compared to drought, earthquake, extreme temperature, landslide, mass movement, volcanic activity, and wildfire. But there was an increase in the flooding events and the storms in the year 2000 to 2019. So climate-related disasters have doubled in the 21st century. Let's take a look at this reality on the ground. This is Baseco. This is the community of Baseco. It's a reclaimed area in between Pasig River and the Manila Bay. Well, this is one of our study sites, and I took these photos. This is during the high tide in Baseco. So coastal communities are the most vulnerable during disasters. They are frontliners during hazardous events. They experience storm surges, flooding. But then during normal times, when there is low tide and high tide, well, you can see children playing on the eastment side of the Pasig River, enjoying the dirty waters of the Manila Bay and the Pasig River, side by side with garbage and plastic. Fast forward to the future we want. Research has found that many people view climate change as a psychologically distant future threat, which leads them to be less motivated to engage in pro-environmental behavior. Engaging in episodic future thinking that is projecting the self into the future to pre-experience future events may facilitate the perception of future events as psychologically close, thereby increasing the perceived risk associated with those events. By future thinking, we imagine possible futures based on current trends, emerging technologies, and societal changes. This is thinking creatively, critically, and holistically about the future and to consider a range of different scenarios. By doing so, we can identify opportunities and develop strategies to address the excessive and abused use of plastic and impacts of climate change. And so, what are these initiatives? So we have Laudato Si as influencer, promoting Laudato Si in various initiatives as part of our course plan, academic activities, capacity building to raise awareness on plastic restriction, partnership with Simbahayan-based communities, collaboration with NGOs and civil societies. Popularizing sustainable development goals, specifically focusing on climate action. And then reflecting on the linear economy to circular economy. What I have presented you about plastic, the story of plastic, is a linear economy model, from extraction, fossil fuel extraction, to production of plastic, to consumption of plastic, and then to the disposal of plastic. Now, we wanted a circular economy model. So, extraction, production, consumption, but then we wanted to divert the disposal of plastic in the landfill by reusing, refilling, repair, recycling, and composting, reducing our throwaway culture. And then advocating ecological waste management to divert waste from the landfill. Then, of course, environmental governance. Well, we have a law on waste management, and what we need is just proper implementation of ecological solid waste management in the local government level. And then, of course, there are also local government units in the Philippines on no to plastic policy, so we will just strengthen and then support these LGUs. What do we envision? One Health is how we envision the future we want. One Health is an integrated, unifying approach that aims to sustainably balance and optimize the health of people, animals, and ecosystems. It recognizes that the health of humans, domestic and wild animals, plants, and the wider environment, including ecosystems, are closely linked and interdependent. Thank you for listening.